So we've seen how the discriminant can help us decide if there are the number of roots of a quadratic equation, whether there are two roots, just one root, or no roots at all. And of course, that relates to the graph because the solutions to an equation or a quadratic equation or show us where the function or the graph of the function will cross the x-axis. Okay, the x values, which will give us in effect y equal to 0. So this is an example, quite a simple example, but a good one nonetheless, of the kind of problem that we can be asked about quadratic equations, their roots. And what we're looking at is asking the question of, here's a quadratic x squared plus k plus 2x plus 4, where we have this k, it's a constant value, and this will change the coefficient in front of x. And we're asking, as we change that coefficient, or k as we change in effect k plus 2, what happens to the roots of this equation? Okay, I'm going to take a pen here. Let's just try this problem here. Well, let's do the pen in black, it's always nice. And we're going to start and remind ourselves about the discriminant. Sometimes we use this letter delta, which is a nice shorthand for that, this formula. Remember, the b squared minus 4ac comes from inside the square root of the quadratic formula. So first of all, identify a, b, and c. Well, a is 1, b is k plus 2, and c is 4. And I have to be able to substitute this in. So we've got k plus 2 all squared minus, and here we'll have a bit of arithmetic. A times c is 4, times 4 again is 16. And we're going to work this out. So k plus 2 all squared is k squared, plus 2k plus 2k is 4k, plus 2 times 2 is 4, minus 16. And we end up with, well, it seems maybe a little bit odd, but we end up with another quadratic. But this time, the quadratic's in k. And this is not an unusual situation, that as we look at these problems of coefficients using discriminant, because of the b squared, we end up back with quadratic equations. That's okay, we can deal with this. What we're interested in is when this quadratic equation is one of three things. When is it greater than 0? When is it equal to 0? And when is it less than 0? I apologize for my rather triangular 0. There we go. Okay, so before I'm going to do that, it would be really helpful if this factorizes. And it's the kind of problem that's set up to factorize, because otherwise it gets a little bit more complicated where we've got not very nice numbers. So let's have a look, and let's just hope that it does. So obviously the factors, because of the k squared, it's k and k. 12 is either 12 times 1, 6 times 2, or 4 times 3. I have a minus, so I'm going to find the difference between these two things. 6 minus 2 is 4. Yeah, I think I'll have a go at 6 and 2 as the values here. Let's see if it works. Well, if I had a plus here, I'd get plus 6k, a minus here, I'd get minus 2k, which would simplify to 4k. So let's just check that. K squared, bracket's not very nice. K squared minus 2k plus 6k minus 12. It works. Okay, so I've got two brackets. Question now is, first of all, let's do the easier problem. And in fact, the easier problem we're going to have is, we're going to go, oops, sorry, let's go back to this. The easier problem is looking at when, get a black pen again, is we're looking at k plus 6 times k minus 2 equals 0. So let's figure this one out first. And we get a nice answer. We get k equals negative 6 and k equals plus 2. Now these 2 points would only have, if we go back to our, if we go back here, we've lost all our writing, don't worry about that. These 2 points, that means when k equals 6 and minus 6, when k equals plus 2, we would get an equation where we would only have, so get my pen back, we would have k plus 6, k minus 2 equals 0, k equals negative 6 and 2. Now these two values, we would not get any, we only get one root. Next question is, well, what's going to happen when k is different values? So I'm going to put a number line here, and I'm going to examine what happens to my quadratic. Well, first of all, when k equals 0, if we look at this, we're going to get, let's imagine it in this region here. Basically, in this region, the equation is 0, okay? So between minus 6 and 2, the value of k, okay, the value of k will either be positive or negative. It can't be 0, okay? Because if it was 0, it would change signs, okay? And if it changes signs, it was 0 again, and it's not, okay? So there's only two places that these two brackets multiply to 0. So in between them, it must be positive or negative. Well, let's have a look. The easiest place to look is at 0. And when k equals 0, plus 6 times negative 2 is negative. So clearly, when k is less than 2, and when k is greater than negative 6, we get no roots, okay? Because the expression here is less than 0. Our quadratic is less than 0. If we look at the side, we can check this. When k equals 3, 9 times 1 is positive. That's okay. So it's positive over here. Let's check over on the left-hand side. When k equals negative 10, let's say, we get negative 4 times negative 12. Negative times negative is a positive, so it's positive over here as well. So when k is greater than 2, and when k is less than negative 6, we get positive. So there'll be 2 roots here, 1 root. So we're looking, remember, at the equation k squared x squared plus k plus 2x, oops, horrible version of that, plus 4 equals 0. And what we've seen is that these values of k, when k equals negative 6 and plus 2, this will have just one root. When k is between negative 6 and 2, we'd get no roots. And when k was greater than 2 and k was less than negative 6, we'd get 2 roots. Thank you.